All right. What do we think we could do to write an equation for each of these tables? Let's start by looking at this left one. We're given an x and a y, like this. How could we go about this? So we notice that our x's are changing by +2. This guy was a +2. How are our y's changing? By nothing. So you can think of it as a +0. This one also changed with +0. So how is that going to help us? What do we learn from the change in the y's and the change in the x's? Why do we want to know that? Because we usually like to write our lines very much like the y equals mx plus b, our slope-intercept guys. The change in y and the change in x, that's what makes m. M we usually think of as our rise over run. Rise rhymes with y's. So we do our change in y over the change in x. Oh, snap. But our y's in this case changed by 0, and our x's changed by 2. What is 0 divided by 2? 0. So if we went to put this into an equation for a line for this one, we'd have y equals 0x plus what? What might our y-intercept be? -2. It's not changing. Our y-intercept happens right in here. We'd want to know what happens when x is 0. And it's not changing, so it's going to be the exact same thing, -2. We could simplify this because 0 times x, well, that's just nothing. So this is going to be y equals -2 as our equation. So that's how we get that one. It's a very similar vibe on the right-hand one. But this time we are actually going to have some values, so snap. So same kind of vibe on this blue one over here. How are our x's changing here? We went +1. And then here we did something different. We went +3. And then we went +1 again. What happened over here? -3. This one is no shame in that calculator game. Use the tools. Do -7, -7 minus 2 is how you get that. We're looking for how it's changing. What's the difference? So you can either do 2 minus -7, which would give you a +9, but we know it's going downwards, so it's going the other way. So both of our pieces that moved up by 1 went by the same amount, and this guy went up 3 and down 3 times what we saw here. So it is a linear equation. This is still a line. Our differences are the same. It's just we took a weird jump here. So to find our slope on this guy, this is where we put our change in y's, our rise, over the change in x's. And it doesn't matter which set we pick. We just have to make sure we get a set that's working at the same step. So you can take the -9 if you also take the 3. You could take the -3 if you take the 1. Doesn't matter which pair you pick, just pick a pair. So we're going to have the change in our y's, which was a -3. Our change in x's, which was a +1. -3 divided by 1 is just -3. I am very rapidly running out of space over here. So then we need to figure out what our y-intercept is going to be. We have our slope of -3. What's our intercept going to be? Erase those two pieces for now. It's not just going to be -3x. -3x plus what? Where is our y-intercept going to be? When x is 0. So x is going to be 0 somewhere in here. Can we figure out what our y value is for that 0? If x is 0, what's our y going to be? Because when we go up a step of 1, we go down how many over here? We go down 3. So if I go up 1 from -1, that puts me at 0, and we go down 3 from 2, where do we wind up? -1. So you can either fill it in, like into your table, kind of like this. You can calculate that value, but that -1 is where we get that. So being able to write an equation from the table is one of those skills that will often show up in the SAT stuff, so we kind of mush together by working an SAT practice question here. Because there will be times that they give you tables and ask you to match it to the equation. Or at least there have been previously. Okay, so this is our equation for this side, and this one's our equation for this side. Any questions on that stuff? Okay. So what we have is about 20 minutes where you guys can pick whatever questions you want to work through on the review, and we can fill them in together. The answer key is posted. If you just want to have work time, that's fine. But if you got any that you want to work through, you just got to let me know a number. Look at your review, flip through it, see if there's any that you want to take a look at. 15 A and B.
Is our class short today?
Yes, we will be done at 48 today. That's why I said we only have 20 minutes. The schedule is up on the front wall on both sides of the screen, and it's on the back wall by the actual schedule. Let's see. Nope, that's not the one. There we go. Oh, 13, 14, 15. There it is. Just a little more. All right. There we go. So we're looking to see our total number of solutions. So first things first, so looking at A over here, how do we know how many solutions this could possibly have? The most solutions it's going to have. 4, yes. It's always going to be that degree. So this is going to have a total of 4 solutions. From that, we're going to look and see, is that even or odd? So is that even or odd? Even. So when we think about our evens, we know it's going to be something that's like kind of like a parabola, but our arrows are going to match. Maybe it points up, maybe it points down. But sometimes it helps to think about a picture. How many roots is this going to have at the very, very most? 4. This can cross a maximum of 4 times. So my picture over here is really bad because it should be like that. Because a 4th degree will cross at most 1, 2, 3, 4 times. How many does it have to have at minimum? What if my axis was down here? Does it have to cross at all? No. Even degreed functions do not have to cross our axis at all. They might have no real roots. So if it's even, it doesn't have to have a solution. It can have no solution. If we have an odd function, so if I had something that was odd, does this one have to cross the axis somewhere? Yeah, whether the axis is down here or up here, since it keeps going, since my arrows go in opposite directions, my axis is going to cross this line somewhere, because even if it's not on the picture, thank you, dear, it's going to cross somewhere. So if we have an odd degree, it has to have one, but even degrees do not have to have any. So let's look at B real quick, since we're right here. How many solutions is it going to have? What's our total? 3. It's our degree. That's how we tell. So the maximum number of roots it can have is 3. It's the same as that degree. This could cross 3 times right here. If I look at this axis, if I cross it here, we have 1, 2, 3. It's the most it can have. What is the minimum number of roots that a third degree function has to have? It has to have at least 1. If my axis is down here, it's going to have 1. If my axis is up at the top, it's going to have 1. If it goes through here, it's going to have 3. So no matter where this curve is placed, it has to cross at least 1 time. Any other questions on that one? Number 13. Let's say, I'm going to erase this because I can't do that. 13, which is, oh, very much like the bell work one we just did. Very, very much like the one we just did. So try and find your slope, how the x's change, how the y's change, and find your y-intercept. These tables actually both have our y-intercepts in there. So you guys can totally do this. This is very, very, very much like the bell work one we just did. How do our x's change? How do our y's change? And you're matching it up to these equations down here. Which one matches? Okay, so that one's just like the bell work. How do our x's change here? So our x's add 1. How much do our y's change? 0. So what's our slope going to be? Zero over 1, which means our slope is 0. Which of these equations down here, I'm going to scroll it away from the little words for a second. Which of these equations has a slope of 0? Say it louder, I couldn't hear you. I still can't tell what you said. Which one has a 0 in front of its x? B. I think that's what that person was saying, but I genuinely could not hear what you said. Just was like a grunt. This is very much like saying plus 0 x's. 6 plus 0 x's. So this one would be a B because it doesn't have any x's here. What's up? Oh, yes. The second folder from the bottom. Okay, so this one would be B. That would be our answer. You could keep going and get all the way to writing your own equation, but at this case, all we needed was what our slope was. Sometimes just finding the slope is enough. What else you guys want to look at? Number 12. So the fully factoring. Same page. Boop. All right, fully factoring the polynomial. You can use whatever technique you'd like. I know there's one I would definitely recommend over others because this, we can work with that. X plus 2, that's a factor that we can do and find its root. We can do this as synthetic division. You do not have to do synthetic division, but on this one, that's probably going to be the easiest way to go. So to get started on this, we're going to take and find when x plus 2 equals 0 to find that root. So we have x equals minus 2 as our root. We're going to use that to set up some synthetic division. The minus 2 goes in the box. That's what we find it for. What numbers are we going to have going across when we set up our synthetic over here? Like this? Bless you. We have to put in a 0. We have an x cubed, and then we jump all the way down to x's. We straight up skipped the squares. So we have to make sure we account for the fact that there's no x squareds in here, so we need to make sure we include that, or we're not going to have the right number of pieces left at the bottom. So you have to include that. It is super duper important. I'm just building a little wall over here because those things were getting smushy together. So we have to have that piece or things are going to go wonky. Our first term's going to drop all the way down. 1 times negative 2 is negative 2. 0 plus negative 2 is negative 2. Negative 2 times negative 2 is a positive 4. When we add these together, negative 3 plus 4, we're going to get a 1. 1 times negative 2 is negative 2, and that gives us a 0 over here. So it's really important that we catch that 0, otherwise we would not have wound up with it being a factor over here. We need to have all those pieces, because we take this, and when we divide out that x plus 2, it gives us down 1 degree. So this guy's now going to be an x squared. This guy's now going to be an x. This guy's are just the number, and this is our remainder. We can only keep going and finding more factors if that remainder is 0. It has to be 0. So once we find that bit, any questions on that part of it? Cool. So I'm going to write this into its quadratic form. So we have our 1x squared minus 2x's, and we have a positive 1 at the end. So this is our quadratic form of what's left over. But that's not finding all the factors yet. I need to see if we can factor that thing. So if we can factor that, we use our x. And you can use the box, you can factor by grouping, whatever technique you like. But we're going to factor that bit. This is when we take our a times c at the top, b goes at the bottom, where our a is this one, and our c is this one. So we have a 1 at the top, and our b is a minus 2. And we're looking to find a pair of numbers that multiplies to make 1 and adds to make negative 2. Negative 1 and negative 1. So when we fill in the box to do the rest of our factoring, we have our x squared from our equation and our 1 from our equation. And then we have our minus 1x and a minus 1x, which means what are we going to get as factors? What is shared between x squared and minus 1x? Just an x. What is shared between minus 1x and 1? Negative 1. This spot is always going to have the same sign as this box. just like this spot is always going to have the same sign as this box. They're always going to match sign-wise. So let's grab our other factor, top row. What is shared between x squared and 1x? And x. And our bottom row, minus 1x and 1? Negative 1. So our factored form of our quadratic piece is our x minus 1 and our x minus 1. And to get our factored form of the polynomial, we need to include our OG guy up here, our x plus 2. Nope, we're going to take our factor over here just the same. Just like when we took our factor and turned it into a root. This is just that it's the root of minus 2. And like these guys would have a root of positive 1. So when we do synthetic division, it's the root. When we have it in factored form, it needs to be the factor, x minus the root. So you can either write your factored form like this, or I know we have a couple people that will notice this, that I have that x minus 1 times itself. You can put this as x minus 1 squared. You do not have to. Like, totally fine. This answer is still 100%. But I know there's somebody who will want to write it like this, and that's 100% okay. But it does need to be written as factors. So this guy or this guy. You don't need to do both. Both are 100% fully complete answers. Questions on this one? Okay, any others you want to work through? Which one?
18A.
18. Can you get there? Finding the quotient. All right, I have to clear this. Anybody need more time with it? Cool. All right. All right, 18A. Finding the quotient. And yeah, we can do A. That's fine. B has a couple of things in it that get a little bit gross as well. This one also has things that are a little bit gross. But that's all right. So we have a quotient thing, meaning we're doing some dividing. If I'm dividing a many-termed thing by a one-term thing, what are we going to do with that? We've got a polynomial and a monomial. How do I divide by a monomial? Split it up into teeny tiny baby fractions. We're going to cut our math into pieces. We're going to divide. I have way too much fun with that, y'all. Oh my gosh. I enjoy it very, very much. It was a brain worm that got in my head, and I cannot let go of it. So we're going to take our 18x to the 8 and divide it by 6x squared. Then we're going to take our 24x to the 7th. I don't know why there's a little dot inside the 24, but there is, and I can't erase it. So we're just gonna have it. It's all good. And we're going to have our minus 16x squared over our 6x squared. So split it up into separate pieces. Whenever we're dividing by a monomial, we're going to put it as separate fractions. So looking at this first guy here, what are we going to get when we have 18x to the 8th and we divide it by 6x squared? What's 18 divided by 6? 3. What's x to the 8th divided by x squared? X to the 6th. That's that I have 8 x's multiplying against each other on the top and 2 x's on the bottom. Cancels out 2. Crosses 2 of them out. How about this middle guy? 24x to the 7th over 6x squared. 4x to the 5th. Okay. And What about this last one? What do we see? Does 16 divide by 6 evenly?
No.
No. Do they both divide by something?
Two.
They both divide by 2, so we could take 16 divided by 2 to get 8, and 6 divided by 2 gives me 3. What happens when we do x squared divided by x squared? They cancel out. That's the same thing as having 1. So we're left with just our 16 over 6, also known as 8/3. So if we have fractions, we have fractions. It's okay. It's unpleasant, but it's okay. We're allowed to have fractions. This is our answer. There's not any more simplifying we can do. The one next to it is going to have some unpleasant fractions as well. But it's good for us to practice seeing that. Theoretically, we have a minute to the bell. That is, if they fix the bells. And are going to give us extra bells. I hope. Okay, so tomorrow is an e-learning day. You guys do have an e-learning assignment up on Canvas because we have to give you a thing. It is combination review problems and practice SAT problems. They're all things you can do. You can have an unlimited number of attempts on them. If you've got questions on stuff tomorrow, feel free to send me emails, Canvas messages, Parent Square messages. I'll have access to my computer throughout the day, just kind of intermittently when I'm not in parent meetings. So feel free to send me messages. Answer keys for everything are up. You can see everything up there. Check all your work on stuff. My goal is to make sure I have everything graded before I leave today, hopefully. I still have a half a test I need to finish grading for my calculus kids, or pre-calc kids. So I'm doing their test first and then as much homework as I can to get everything caught up before tomorrow. I will still be open during 5th period today, yes. Grabbing I did do attendance. Look at me outsmarting myself. I was like, I didn't do attendance. Yes, I did. They're not giving us bells, are they?
I don't think they are. So annoying.
I know they can change them because they turn them off sometimes
Yeah.
for parent-teacher conference day, but not often. There we go. We're going to do it manual mode.